Foundations of Mathematics, MPM 2D. 1. Enhanced Understanding. The Foundations of Mathematics, MPM 2D, course facilitates students in deepening their comprehension of mathematical relationships, advancing their problem-solving abilities, and honing their algebraic skills through inquiry-based exploration, technological applications, and abstract reasoning. 2. Focus areas. Students will delve into quadratic relations and their practical applications, master the solution and application of linear systems, analyze geometric properties using analytic geometry, and investigate the trigonometry principles of right and acute triangles. 3. Critical thinking. Through this course, students will use mathematical reasoning to tackle multi-step problems and effectively communicate their thought processes as they navigate complex mathematical scenarios. 4. Curriculum alignment. The course aligns with the Mathematics Curriculum Policy document for grades 9 and 10 in Ontario, providing students with a structured and comprehensive framework for learning mathematical concepts and applications. 5. Academic orientation. Foundations of Mathematics is categorized as an academic course. It offers students a thorough grounding in mathematical principles and techniques to prepare them for further studies in mathematics and related disciplines. 6. Credit value. The course carries a credit value of 1, contributing towards students' academic progression and fulfilling credit requirements towards their overall scholastic achievements. 7. Prerequisite knowledge. Students are required to have completed MPM 1D, Principles of Mathematics, grade 9, as a prerequisite to ensure a foundational understanding of mathematical concepts and prepare them for the more advanced topics covered in MPM 2D. 8. Skill development. Students will sharpen their problem-solving skills, algebraic proficiency, technological literacy, and critical thinking abilities, equipping them with the essential mathematical tools and strategies needed for academic success and real-world applications. 9. Integrated learning. The course integrates mathematical theory with practical applications, encouraging students to apply mathematical concepts in various contexts and translating abstract mathematical principles into tangible problem-solving strategies. This course is comprised of 3 units and a final assessment as follows. Unit 1. Analytic Geometry, 33 hours. 1. Introduction to Analytic Geometry. Students will delve into the fundamentals of analytic geometry, gaining an understanding of key tools and techniques utilized in geometric problem-solving scenarios. 2. Quadrilateral classification. Through the application of analytic geometry tools, students will analyze and classify quadrilaterals based on their defining properties, enhancing their ability to identify and differentiate various geometric shapes. 3. Integration of knowledge. Students will integrate their understanding of analytic geometry tools with their comprehension of linear relations, enabling them to tackle complex geometry problems by applying a combination of geometric principles and algebraic concepts. 4. Problem-solving skills. This unit will focus on developing students' problem-solving skills within the realm of analytic geometry, equipping them with the analytical prowess to approach and solve intricate geometric puzzles and challenges. 5. Hands-on exploration. Through hands-on activities and practice exercises, students will engage in the practical application of analytic geometry tools, honing their spatial reasoning abilities and geometric visualization skills. 6. Critical thinking. The unit will emphasize critical thinking skills as students analyze geometric scenarios and apply analytic geometry tools to reason through problem-solving tasks, fostering logical reasoning and strategic decision-making. 7. Concept integration. Students will be encouraged to connect and integrate concepts from analytic geometry and linear relations, recognizing the interconnectedness of mathematical principles and their applicability in solving geometric problems. 8. Properties-based analysis. By understanding and applying properties of quadrilaterals, students will learn to identify unique characteristics and classifications of various geometric shapes, enhancing their geometric vocabulary and analytical proficiency. 9. Real-world applications. The unit will emphasize the practical relevance of analytic geometry in real-world contexts, demonstrating how geometric concepts and tools are utilized in fields such as architecture, engineering, design, and other applied disciplines. Unit 2. Quadratic relations in the form y equals x squared plus bx plus c, 34 hours. 1. Quadratic relation exploration. Students will delve into the properties and characteristics of quadratic relations in the form y equals x squared plus bx plus c, gaining a deeper understanding of the relationship between the coefficients a, b, and c in quadratic equations. 2. Vertex form application. The unit will focus on the vertex form of quadratic equations, and students will apply the properties associated with this form to graph quadratic relations, enhancing their ability to analyze and interpret the behavior of quadratic functions. 3. Conversion process. Students will learn the process of converting quadratic relations from standard form to vertex form, developing a strategic approach to transforming equations and simplifying the algebraic representation of quadratics. 4. Graphical representation. By graphing quadratic relations based on vertex form and standard form equations, students will visualize the parabolic shapes of quadratic functions and gain insight into the geometric properties of these curves. 5. Real-world problem solving. Students will apply their knowledge of quadratic relations to solve real-world problems, such as determining maximums and minimums in quadratic models, and translating abstract mathematical concepts into practical solutions with real-world relevance. 6. Optimization techniques. Through the analysis of maximum and minimum points in quadratic functions, students will explore optimization strategies, identifying optimal solutions in various contexts and scenarios where quadratic models are applicable. 7. Critical thinking skills. The unit will emphasize critical thinking and problem-solving skills as students navigate quadratic equations, considering the implications of vertex form, graph transformations, and optimization principles in mathematical reasoning and decision-making. 8. Practical application. Students will engage in hands-on activities and problem-solving exercises that involve applying quadratic relations to real-life situations, fostering a deeper connection between mathematical concepts and their utility in solving everyday problems. 9. Conceptual understanding. By exploring quadratic relations in vertex form and standard form, students will build a strong conceptual foundation in quadratic functions, preparing them to analyze, interpret, and manipulate quadratic equations effectively in a variety of mathematical and real-world contexts. Unit 3. Trigonometry, 34 hours. 1. Trinomial expression representation. Students will learn strategies for expressing trinomial expressions in different forms, enhancing their ability to manipulate and work with complex mathematical expressions involving 3 terms. 2. Strategic problem solving. The unit will focus on developing problem-solving skills related to trinomial expressions, emphasizing the selection of the most effective strategies for tackling mathematical problems that involve trinomials. 3. Skill development. Students will refine their mathematical skills and analytical thinking by practicing various methods for representing trinomial expressions, preparing them for more advanced mathematical concepts and problem-solving techniques. 4. Effective strategy selection. Emphasis will be placed on the importance of choosing the most efficient and appropriate strategies when approaching problems involving trinomial expressions, fostering a methodical and strategic approach to mathematical problem solving. 5. Foundational abilities. The skills developed in this unit are foundational and essential for mastering trigonometry concepts, laying a solid groundwork for students' understanding of more advanced topics in mathematics. 6. Relevance to future studies. The abilities cultivated in representing trinomial expressions will not only benefit students in this course but also serve as a stepping stone for their future studies in mathematics, providing them with a strong foundation for continued learning. 7. Analytical thinking. Students will enhance their analytical thinking and reasoning skills through the exploration of different forms of trinomial expressions, strengthening their ability to analyze mathematical problems and arrive at effective solutions. 8. Problem-solving proficiency. By practicing strategies for representing trinomials, students will improve their problem-solving proficiency, enabling them to approach mathematical challenges with confidence and apply appropriate techniques to solve complex problems. 9. Mathematical foundation. This unit will contribute to building a strong mathematical foundation for students, equipping them with the skills and strategies necessary to succeed in trigonometry and beyond, laying the groundwork for their mathematical journey. Final exam, 3-hour. 1. Assessment importance. The final exam is a crucial evaluation component designed to assess students' understanding and mastery of the course material. 2. Proctored format. The exam will be proctored to ensure academic integrity and fairness, adhering to established guidelines for examination supervision. 3. Time allocation. Students will have a total of 3 hours to complete the exam, providing a specific time frame to demonstrate their knowledge and skills. 4. Weightage significance. The exam carries a weightage of 30% towards the final grade, signifying its importance in determining students' academic performance. 5. Comprehensive evaluation. The exam will cover a range of topics and concepts encountered throughout the course, testing students' depth of understanding and ability to apply knowledge. 6. Academic integrity. The proctored format emphasizes the importance of upholding academic honesty and ethical conduct during the examination. 7. Preparation strategies. Students are encouraged to prepare effectively by reviewing course materials, practicing past exam questions, and seeking clarification on challenging topics. 8. Performance assessment. The exam will evaluate students' critical thinking, analytical skills, problem-solving abilities, and application of course concepts in solving problems. 9. Academic achievement. Successful completion of the exam demonstrates students' proficiency in the subject matter and contributes significantly to their final grade in the course. By the end of the course, you will have achieved the following overall expectations. A. Quadratic relations of the form y equals x2 plus bx plus c. 1. Understanding basic properties. Students will grasp the fundamental characteristics and properties of quadratic relations, including vertex, axis of symmetry, roots, and concavity, enabling them to analyze and interpret quadratic functions effectively. 2. Graph transformations. Students will learn to relate transformations of the standard parabolic graph y equals x2 to the vertex form representation y equals a xh 2 plus k, exploring how changes in a, h, and k shift, stretch, or reflect the graph, thereby developing visual intuition and understanding of geometric transformations. 3. Equation solving. Students will acquire the necessary skills to solve quadratic equations using various methods such as factoring, completing the square, and using the quadratic formula, and interpreting the solutions in the context of the corresponding relations on the graph. 4. Problem-solving proficiency. Students will apply their knowledge of quadratic relations to solve real-world and theoretical problems involving quadratic equations and functions, honing their problem-solving abilities and critical thinking skills. 5. Application of mathematical concepts. Through the study of quadratic relations, students will deepen their understanding of mathematical concepts such as roots, vertex, discriminant, and line of symmetry, equipping them with the tools to analyze and interpret quadratic functions in different contexts. 6. Critical analysis. Students will critically analyze the behavior of quadratic relations, including how changes in coefficients a, b, and c impact the shape, position, and characteristics of the graph, enhancing their ability to make informed mathematical decisions and predictions. 7. Numerical interpretation. Students will interpret the numerical solutions of quadratic equations in relation to the graphical representation, developing insights into how the roots correspond to the x-intercepts and the significance of these solutions within the context of the problem. 8. Problem resolution. By applying their understanding of quadratic relations and equations, students will practice identifying, formulating, and solving problems involving quadratic functions, developing proficiency in modeling real-world scenarios mathematically. 9. Comprehension and application. Through mastering quadratic relations of the form y equals x2 plus bx plus c, students will not only understand the theoretical aspects of quadratic functions but also be able to apply their knowledge to analyze, interpret, and solve mathematical problems related to quadratics effectively. B. Analytic geometry. 1. Intersection of straight lines. Students will develop the skills to model and solve problems related to the intersection of two straight lines, applying analytic geometry techniques to determine the points where the lines meet or are parallel. 2. Analytic geometry problem solving. Through the course, students will tackle various problems that involve the properties of lines and line segments using analytic geometry, utilizing equations, coordinates, slopes, and distances to solve geometric challenges effectively. 3. Verification of geometric properties. Students will learn how to verify geometric properties of triangles and quadrilaterals with precision and accuracy by applying analytic geometry, ensuring the validity of relationships such as angles, side lengths, and geometric configurations using mathematical tools and concepts. 4. Line segments analysis. The course will equip students with the ability to analyze and interpret properties of line segments, including lengths, midpoints, slopes, and intersections, enabling them to make geometric connections and solve problems related to line segments effectively. 5. Coordinated problem solving. Students will hone their problem-solving skills by utilizing coordinate geometry techniques to analyze and solve geometric problems, fostering a deeper understanding of geometric relationships and properties within the Cartesian coordinate system. 6. Application of geometric principles. By engaging with analytic geometry applications, students will gain practical experience in translating geometric principles into mathematical equations, graphs, and solutions, enhancing their ability to derive conclusions based on analytical reasoning. 7. Logical reasoning. The course will emphasize the development of students' logical reasoning skills as they apply analytic geometry principles to verify geometric properties, encouraging structured thinking and systematic approaches to problem solving. 8. Triangulation techniques. Students will learn how to apply triangulation methods using analytic geometry to prove and validate properties of triangles, such as congruence, similarity, and angle relationships, facilitating a deeper understanding of triangle geometry. 9. Quadrilateral analysis. Through the lens of analytic geometry, students will investigate and analyze properties of quadrilaterals, such as the lengths of sides, diagonal relationships, angles, and symmetry properties, enhancing their geometric knowledge and problem-solving proficiency within quadrilateral geometry. C. Trigonometry. 1. Similar triangles investigation. Students will apply their understanding of ratio and proportion to explore the concept of similar triangles, identifying relationships between corresponding sides and angles to solve problems related to similarity and congruence. 2. Right triangle problem solving. Students will utilize the primary trigonometric ratios, sine, cosine, and tangent, and the Pythagorean theorem to solve problems involving right triangles, leveraging trigonometric functions to calculate side lengths and angle measures in geometric scenarios. 3. Acute triangle challenges. Through the use of the sine law and the cosine law, students will tackle problems involving acute triangles, determining side lengths, angle measures, and triangle properties by applying these trigonometric laws and formulas to analyze acute triangle configurations. 4. Ratio and proportion applications. By employing ratio and proportion principles, students will investigate the properties of similar triangles, uncovering proportional relationships and applying these concepts to solve geometric problems related to triangle similarity and congruence. 5. Trigonometric ratios mastery. Students will develop proficiency in applying trigonometric ratios, sin, cos, and tan, to solve problems involving right triangles, enabling them to calculate side lengths and angle measures based on the given information and trigonometric relationships. 6. The Pythagorean theorem utilization. Through the application of the Pythagorean theorem, students will solve a variety of problems concerning right triangles, verifying the relationship between the squares of the triangle's side lengths and the length of the hypotenuse. 7. Sine law utilization. Students will apply the sine law, which relates the lengths of sides to the sines of the opposite angles in a triangle, to solve problems involving acute triangles, utilizing this law to establish trigonometric relationships in triangular configurations. 8. Cosine law application. By utilizing the cosine law, which establishes a relationship between side lengths and cosine values of angles in a triangle, students will solve geometric problems involving acute triangles, applying this law to determine side lengths and angle measures within the triangle. 9. Problem-solving proficiency. Through the study of trigonometry concepts and applications, students will enhance their problem-solving skills, geometric reasoning, and analytical abilities, equipping them with the tools to navigate and solve a diverse range of triangle-related problems using trigonometric principles.